Today's lesson, we're going to cover looking at interpreting graphs, which is section 2-2, and also constant proportionality from tables, which is 2-3. And you're going to have to cut out the note sheet. So please add these 2 pages to the notebook, page 21 and page 22. But before we get to these 2 pages, we are going to look at the topic 2 vocab that we added in earlier and update the first one. So on page 16, you should have proportional relationship. The definition is a relationship where the ratios are equivalent and constant. So for example, if we have a table with 4/2, that is equal to 2/1, then that would be proportional to the ordered pair 2/1, because 2 times 2 is 4 and 1 times 2 is 2. So 2/1 is the constant of proportionality that causes this to be a proportional relationship. If we have a graph, the graph is going to be a straight line that goes through the origin. So on our non-example, we need to fill in some values that are not proportional, so they would not result in the same ratio. So you could have 2/4, and then you could have 3/5, because 4/2, excuse me, if we did that one, would equal 2, but 5/3 would not equal 2. And then on the non-example, we could have a straight line that doesn't go through the origin. Why don't you could do like a curved line that doesn't go through the origin. So that would be a non-example. The characteristics for this is matchy-matchy, and I'm going to show you an example of that, and straight through the origin. Matchy-matchy, kind of like this model who all of her pieces of attire and accessories are matching. Over here, these ratios would be from a proportional relationship, because 3/5 is equal or equivalent to 6/10. It's also equivalent to 12/20. And you could do any common multiple. You could do times 10 and get 30/50, or times 100, 300/500. As long as you multiply by the same number, they are all going to be equivalent and matchy-matchy. Okay, now we're on page 21. It's a little half sheet notes with 2 examples, example 1 and example 2. So we're going to start with example 1. The following graph shows a proportional relationship between the length of a trip and the cost of a taxi ride. So the distance and the cost. What does point A represent? So when we look at point A, we're going to go and do our y over x. So A would represent $8 per 20 kilometers driven. So $8 per 20 kilometers. So it costs $8 to travel 20 kilometers. And then 1b, what is and I've written it on the note, simplified y over x ratio from the graph. So we want to find out what 1 kilometer is worth. So our y over x simplified. So y is this side. So we have 8/20. And if we divide by 20, we'll get a unit rate, and it will be 40 cents. So it's 40 cents per kilometer. Therefore, how much would a 52-kilometer trip cost? Well, you'll notice 52 is not on the graph, so we can't use the graph for that. So we have to use this value. So if it's 40 cents for 1 kilometer, then to get 52 kilometers, we're going to take 40 cents and multiply by 52, and we will get $20.80. For some reason, my PowerPoint, this is the dollar sign, should say $20.80. Example 2, the graph predicts how much time it takes to hike certain distances. So how far is one expected to hike after 3 hours? So a person who hikes 3 hours is expected. Now this is where you have to figure out what is this value, because it's not labeled. So if every 2 squares is 5, we have to divide 5 by 2 to figure out what halfway is. Well, 5 divided by 2 to figure out this value is going to be 2.5. So therefore, this is 2.5. 5 plus 2.5 is 7.5, 7.5. And so after 3 hours, someone has hiked 7.5 kilometers. What is the simplified y over x ratio from the graph? Well, we have right here, 1 is equal to 2.5 kilometers. So 2.5 kilometers per 1 hour. Then what's the distance traveled after 10 hours? Well, You could go to 5 hours and double it, or you could take the 2.5 kilometers, which is equal to 1 hour, and multiply by 10, and we'll get 25 kilometers. Okay, we're on to the second notes page, but before we write any notes, just want to explain the college rivalry example. You can look here. A common rivalry in the Bay Area is Cal, which is Berkeley, versus Stanford. So we have the Stanford-Cal rivalry set up here. I went to college at UCLA, and it has a huge rivalry to USC, University of Southern California, versus University of California, Los Angeles. Huge rivalry. So I went ahead and used an example of the tuition costs between the two schools as our constant proportionality example. So here's something just for my rivals. And this is not on the notes, so that's why the symbol's here. This is just an example. So if it costs $98,928 to be enrolled for 2 years, by the way, I looked up this information back in 2015, so I'm sure the tuition is actually even more than this now. But back then it was $98,928 for 2 years. So therefore, if we do our y over x and figure out our unit rate, we're going to get $49,464. And if we do the same for all of these, it's going to equal the same amount, because this represents, and it asks us, what does this constant of proportionality represent? Our y over x ratio is $49,464 per 1 year. So it costs that much money to attend USC for 1 year, which is a lot. So now we're on the notes sheet. This is the one you have to cut out, and it folds, and we're going to be in the top flap. That is the UCLA tuition example. So that's my college, Bruin Nation, which is an excellent college. And if anyone ever wants to talk about UCLA, please talk to me. Okay, so on this example, we have it's $39,753 for 3 years. So we're going to divide our y over x and get $13,251 per one. So if we do the same for all these values, we should get the same thing because it's proportional, which it is. And therefore, the constant proportionality tells us that the total cost for 1 year is $13,251 to attend UCLA for 1 year, which is still expensive, but quite a bit less than USC. And once again, this is information from, I think, 2015, so a number of years ago, but still probably relatively close nowadays. So this is a meme for our next example about Destiny, the video game. So this is about the raids that go on in Destiny. So after so many raids, there's a total number of loot earned. So to figure out the constant proportionality, we do y over x. We divide and simplify and get 4 over 1. This will be the case for all the values. So our constant proportionality is 4 over 1. What does that tell us? What tells us the y value is total loot earned. So for 4 loot earned, we would expect to get that after 1 raid. So 4 loot items are earned per raid. And then if I was to ask how much loot would you expect to get from 9 raids? Well, if it's 4 per 1, then 4 times 9 would be 36 loot items. And now we're in the middle of your notes. We have movie theater advertising represented by this table. So to show advertising on 20 screens, it costs $26,900. So if we find the constant proportionality for each of these, take the value, divide by 20, take this value, divide by 15, take $168,125, excuse me, divided by 125, and we will get 1,345 as our constant proportionality. Well, that is a total cost per 1 screen. So it costs $1,345 per 1 screen of movie advertising. How much would it cost to advertise on 32 screens? We'll take that, multiply by 32, and we'll get $43,040. Which is pretty expensive. And that's the last example for the notes today.